So for tonight's session, essentially what we're going to be doing is going through a lot of the core basics for the Python programming language. It is recommended that you open Google Colab, COLAB, as in boy, before initiating this session. Google Colab is a coding interface that will allow you to code in Python while you are in session. Okay, and I can go ahead and show you exactly what the Google Colab looks like. Let's go ahead and type that in here. Let's share this particular tab. So the Google Colab will be here. So you search Google Colab, COLAB, and then you'll be able to enter a Google Colab session. So you can get you a Google Colab notebook. So go ahead and hit that. And then let's say that you want to open a new notebook. You can go to File here and hit Open Notebook. And then you can hit from here, let's see, which one would you want? You can hit this Welcome one. And then what you can do is just go ahead and delete some stuff here. And then go ahead and hit a coding cell. And then you can start coding from here. Okay. So this is the Google Colab. All right. So let's go ahead and hit back here. Okay, wonderful. For today, what we'll be doing is going over the Python programming language and going over a lot of the basics with Python. So first, we'll start off with a simple introduction to Python. And then after we do the simple introduction to Python, we will go over some of the coding practices. So here we are, June 21st, 2024. We're going over the Python programming language introduction. And during this phase, we'll go over some of the history. And then after, we will go over all of the hands-on techniques that you can utilize with Python. Okay. So first, let's go ahead and go over some of the history here. Okay. So in regards to the history, so essentially what we have here is the history of the Python programming language. So originally, the Python programming language was built on a language called C. It was originally conceived in the 1980s by Guido van Rossum and first released in 1991 as Python 0.90. All right. The second release of Python was in 2000, and it was as Python 2.0, which can handle more Unicode. The third release was in 2008 as Python 3.0, which is what we commonly know Python as today, the universal programming language that can be used for almost anything. So Python is a language that has been developed for many decades now, and it's one that is very convenient to a lot of conspecifics. So people of various industries are utilizing Python, pretty much from statistics to computer science to the biological sciences with bioinformatics and much more. So the Python programming language is one that you will really want to continue to advance in, for it's one that is steadily evolving. Okay. And its use cases are phenomenal. It can be used for many things. And that's what we'll go ahead and go over today. So let's go ahead and move forward here. So here are some of the Python use cases. So Python can be utilized for web and software development via the Django programming interface. Okay, so you can utilize Django Python in order to build software and web platforms directly from the ground up. So it's a very beautiful programming interface that's based on Python that will allow you to take your Python abilities to the next level. Okay, so this is just one use case that you can utilize Python for. It also has a plethora of other use cases. So for example, Python can be utilized for data analytics and data science. So if you want to do any data visualizations, for example, or any exploratory data analyses, or even if you want to go further than that, if If you want to go into artificial intelligence and do machine learning, which is pretty much just basic statistics, if you want to do machine learning, you can do that. Or if you want to really get into neural networks and do deep learning, you can do that as well with the Python programming language. Okay, so it's a phenomenal language that can be used for your analytics and your data science side of things. Okay. So that's another use case of Python, and a lot of corporations they tend to utilize Python on more of the data science side to see how business is performing, to check on finances and things of that nature. And even if you look at the biological sides, if you go to a lot of the biotech companies, they check their performances with Python as well, and they also look at health informatics with Python, so checking out certain types of genes and relating it to certain types of diseases. Okay, but that's not all. Python can also be utilized for robotics. So with robotics, you have something called Arduinos. These are smaller mechanisms that have motors and so forth. These Arduinos can be powered to what we call GPIOs on many motherboards, like the Raspberry Pi, for example. Once you plug it into the GPIOs of those motherboards and you perform your coding with the Python, you'll be able to pretty much set the functionality of those particular GPIOs to the Arduino, ultimately getting it to operate the way that you want. So if you want for the motor to turn on every 1 to 3 seconds, you can have it to do that. If you want for it to turn off after a certain point in time, you can have it to do that. If you want for the motor to trigger when you press a certain button, you can have it to do that as well. Or even with the LED light, you can code that up with Python as well and have that hooked up to the motherboard or the Raspberry Pi. Okay, so that's a smaller level project, but it also has larger applications. Tesla Motors, for example, utilizes Python for a lot of their coding as well. Uh, so it's something to definitely think about when you're utilizing the Python language. How exactly do you want to utilize Python? What do you want to utilize it for? And how will you apply it to your particular career? Okay, so that's just a few examples of use cases of Python. And as mentioned previously, Tesla utilizes Python for object and image detection. They're able to track different types of paths and make sure that the car is able to be on autopilot. So they're able to do many wonderful things with Python. Instagram was built on Python with Python Django. So this entire application that is used by millions and millions of people was built on the Python programming language. All right, so that's Instagram. All right, so let's go ahead and get started. So if you want to utilize the Python programming language, you can either utilize the Google Colab that was shown previously, or what you can do is download what we call Anaconda. Now with Anaconda, I do have the download link here. You just go to anaconda.com/download, and then you can download Anaconda. And essentially what that will allow you to do is access something called Jupyter Notebook. With Jupyter Notebook, you'll be able to do a lot of your programming directly within your system infrastructure. And you can do all of this directly from your browser. But actually, I wouldn't even recommend Jupyter Notebook. I would recommend Jupyter Lab. That's the newer version of Jupyter. So if you use Jupyter Lab, it has a better interface. It's very smooth, and it's more modern, I would say, if you like a more modern interface. So when you download Anaconda, you will see Jupyter Notebook, and you will also see Jupyter Lab. Okay, so definitely check those out once you finish downloading Anaconda, and see which one you like better personally. Okay. There's another thing that you'll want to download, and this is Git. So there's a system infrastructure where you can download all of your data. It's called GitHub. And if you go onto GitHub, that's pretty much your data resume. So if you have certain projects that you're working on that you want for corporations to see or for employers to see, you can upload all of your projects to what we call GitHub. Okay. So that will be after downloading Git, and pretty much from that, you'll be able to port a lot of your data onto GitHub for your professional portfolio. Okay, and this is where GitHub comes into play. So you want to get into GitHub here. All right, and as mentioned previously, Google Colab is how you can quickly get started with your Python coding. So you can quickly go to Google Colab or colab.research.google.com, and then you can open up a notebook and start coding in Python right then and there with Google Colab. Okay, and a cool part about Google Colab is that you can collaborate. Yep, collaborate with other individuals. So if you had a buddy that you wanted to hop onto that same notebook with you, you can go ahead and send that invite to them. They can hop onto that same notebook, and then you all can start coding together. So that's the beautiful part of Google Colab. Okay. And there are a lot of essential packages that you will want to have installed before getting started with Python. And you'll do this in what we call a terminal. Okay. So in your terminal or command line, if you type in CMD onto your search bar for your computer, you'll see your command line pop up. So if you type in pip install, you'll be able to pip install pandas, you'll be able to pip install matplotlib, and you'll be able to pip install numpy. Okay, these are crucial packages for any coder that utilizes the Python language. So pandas is primarily utilized for data analytics. Okay, so you can get what we call data frames. These are tables. You can have entire tables of data that you can sift through. You can filter it by column. You can do a lot of amazing things with the pandas package. All right, and you can also give it a nickname. So if you were present during the prequel courses to the summer, we had the nickname explanation. So you can import pandas, but as soon as you put that as, you're giving it a nickname. So you can import pandas as PD. All right, that's the popular nickname for pandas, PD. And then matplotlib, this is primarily used for data visualization. Okay, so if you want to visualize your data, if you want to see a bar chart or a scatter plot or anything of that nature, you can utilize matplotlib. Okay, so you can do that by typing in import matplotlib.pyplot as PLT. All right, and it's a small typo there. That's not matplotlib, it's matplot, PLOT, lib.pyplot as PLT. PLT is the popular nickname for matplotlib. All right. And then if you want to check out data arrays and matrices and things of that nature, which is very crucial if you're doing a machine learning algorithm or doing a train test split, anything of that nature, you'll utilize numpy. Okay. So that is used for data arrays and modifying your data. Okay. So you can do that one by doing import numpy as NP. NP is its nickname. All right, and that's just a quick introduction to Python. Now we're going to go ahead and transition to the actual coding with it. But I do want to see if there are any questions so far. So any questions, feel free to put it in the chat if you have any questions, and then I should be able to assist. All right, brilliant. Thanks, Kush. No questions. All right, let's go ahead and transition to the next sector. Let's go ahead here. All right. So we've made it. We've made it to the beginner steps on how to code with Python. So let's go ahead and move forward. So whenever you're coding with Python, it is crucial to know the different types of data that are out there. Okay, so there are several different types of data that are out there, and let's go ahead and start off with the first here. So one will be a string. Okay, So a string is what I would call immutable. So it cannot be changed once it's string. Once it's typed as string, that type of data cannot be changed. So if you have a string, that type cannot be changed. So it's considered immutable. Okay, that's something that you'll hear in a lot of interviews. When you're interviewing for a Python position, they will wonder whether or not something is mutable, which is changeable, mutatable, or immutable, which is not changeable. It cannot be mutated. Okay. So the string, this one commonly includes letters, or it can have integers or symbols and punctuation. All right. So as you can see here, this one's in those quotations there. Hello world, 1, 2, 3. Only when it's in these quotations here can it be considered a string. Okay. And then welcome, prepare to master data. Okay. So only when it's in those quotations can it be considered a string. If it's not in those, this 1, 2, 3 here will be considered strictly integer. Okay. So it'll be strictly integer. Another type of data will be a Boolean. So that is whether or not something is true or whether or not something is false. These are popularly utilized in if statements. So if you want something to happen, let's say if 1 is equal to 1 and output is true, then something will happen. Else, so it's an if-else statement. Else, have something else happen. Okay, so that's with your if statements in Python. But here, we're just going to go over the basics of a Boolean. So what you can do is bool, like here. Then you can put it in the function here, the bool function. If 1 is equal to a, give us an output. The output will be false. Then with this input here, if 1 is equal to 1, then give us true. Then it gives you that true as an output. So that's what a Boolean is. It just determines whether or not something is true or false. And then we have our integers. So here's something with numbers. You have your integers, and then you have your floats. Floats are anything with a decimal. Integers are those that are whole numbers. So it has to be a whole number, no decimal at all. If it has a decimal, it's classified as a float. If it does not have a decimal and it's just a whole number, it's classified as an integer. Remember, these types of data are classified as immutable. Once it's that type, it cannot be changed. An integer is always an integer. A float is always a float. A string is always a string. And a Boolean is always a Boolean. Those things are immutable. They cannot be changed. Okay. So here are some examples of floats. So these are your beautiful floats here: 1.3, 2.872, 3.21652. All of these things are types of floats here. Okay. So let's go ahead and move to the next sector here. Let's see here. All right, and then you have what we call trash data. These are NaN, not a number. Okay, you'll see a lot of these in your data frames or tables. Okay, and each of these columns here, or dimensions, or features. Now, there's a reason why I said 3 things there: columns, dimensions, features. As you advance into artificial intelligence with Python, you'll start to hear something called dimensionality reduction. Each column, name, age, marks, these are all classified as dimensions, or they'll be classified as features depending on the statistical method that you're using. Um, the more dimensions that you have, or columns or features that you have when you are doing an analysis, the more of a chance that you'll have something called dimensionality or curse of dimensionality. If you have that curse of dimensionality, the output for, let's say, a predictive model will not be as accurate as you would have wanted it to be. The accuracy of whatever you're studying will not be as accurate as you may have wanted it to be. So it's always crucial to check out dimensionality, understand dimensionality before doing any type of artificial intelligence, machine learning analyses. Okay. So that's a quick tip for the future. But again, here are these NaN values, these not a number values. They are junk data, and in many cases, you can drop columns that have it because they're incomplete data sets, right? Or rows that have. You want to drop those rows, not the column. You want to drop the rows. So the rows that have it, you can drop this row. So the Akriti Goel, you can drop this entire row, or the Sanskriti, you can drop this entire row because it has that NaN value and it's junk data, and it doesn't have all the values that you need to properly conduct an assessment. All right. So in many cases, people drop NA. That's a method for um, for pandas. So with the pandas package, you can utilize pd.dropNA and go ahead and drop these particular rows here that have that trash data. Okay. So that's a part of data cleaning, and that's something that we'll explore here. Okay. So let's go ahead and go over this stuff here, the quantitative and qualitative data. So your quantitative data is numerical data that is continuous or discrete. All right, so that's more so your continuous data. All right. Then you have your qualitative data. This is your descriptive data. So it's not numbers, but it can be discrete data. So it can be like, let's say, for example, man or woman, something of that nature will be considered your qualitative. Your numerical data for quantitative, that's what it is, just numbers. You will have more of your numbers there. Okay. Or let's go back to qualitative here. You can have red, blue, things of that nature. Red, blue, man, woman, adult, cat. Things like that can be under qualitative. Now let's go a bit more into detail here. So with your continuous data, it's data that can be infinite and of various values. So it'll be non-consistent, and it's great for linear regression or linear models. Okay. So you can have just basic numbers. You can have the time. You can have your weight. You can have a speed or velocity, miles per hour. You can have your height, or you can even have distance. Okay. So these are things that can be infinite and of various values. It's non-consistent. That's your continuous data. Now let's go back here. That continuous data will be under quantitative data. Okay. That'll be under quantitative data. Then you have your discrete data. Remember, discrete data can be under quantitative as long as it's numerical, or it can be under qualitative. Okay. So let's look at this discrete data. So discrete data is finite. Okay. So it's not infinite, it's finite. All right. It's limited. So it's finite data that cannot be measured. All right. It's consistent, it's still, and it's countable. All right. With continuous data, it's not countable because it's continuous. It's ongoing. It's infinite. But with discrete data, you can count that. All right. It has a limit to it. Okay. So it's the number of children at a daycare on day one. All right. So that'll be equal to 5. On day one, there were only 5 students there. Okay. It's finite, it's limited, and it's countable. Okay. Or the number of students in the class. Oh, how many students are in the math class for this year? 30. You have 30 students in this particular math class. Remember, it's finite, it's countable, and it has a consistency to it. It's always 30. Or the number of crayons in a crayon box. You always know that number of crayons in a crayon box. Of course, unless one is lost, so then that will be a problem. But in general, you know the number of crayons in a crayon box. And remember, this discrete data can be under quantitative if you're dealing with numbers, or it can be under qualitative data. So it's more descriptive data. Okay, so it's not always numbers. This will be considered quantitative since we're looking at the number here. Instead, it will be 1 second. Sorry about that. Was receiving a phone call. But instead, when you're counting the number of it, that will be under the quantitative data. If you're looking at something more descriptive that is limited, that will be under qualitative data. Okay. So now let's go ahead a bit deeper into things here. So you have your binary data as well. This is great for your logistical analyses. Now, once we get to artificial intelligence and you're looking at the neural networks, you'll see that logistical regression, and you're looking at a neuron, that logistical regression is known as a sigmoid. And we'll be covering that deeper into the summer. But a sigmoid will be classified as your logistical regression. And it consists of zeros and it consists of ones. Okay. So 0, 1, 0, 1, 0, 1, 0, 1. That will be your logistical regression, binary data. Okay. And you can also have it as not only integers as 0, 1, but you can also impute that as boy or girl or cat or dog or black and white or yin and yang. It can be categorical data. Okay. So when you're thinking of binary data, it's not always just zeros and ones, but it can also be other binaries as well. So like black and white here, or yin and yang. Okay. And you will utilize anything that's binary and categorical like that with logistical regression. So whenever you want to do an analysis on something and it's two things, you want to do logistical regression. Okay. That's binary data. All right. So this is another type of data, binary data. And now earlier we were going over the types of data here, the mutable versus immutable. So let's go ahead and go back to this. So mutable or mutatable data is something that can be changed, whereas immutable data is something that cannot be changed, or data that cannot be changed. So if you look at this here, a list, a set, those are things, or even a dictionary. Those are things that can be changed, that are mutatable or mutable. All right. But things that are strictly a type, like a string or an integer or a Boolean or float, those things are immutable. So they cannot be changed. They cannot be mutated. Okay. So always keep that in mind whenever you're coding or whenever you're on the job interview and they try to ask you what's the difference between mutable or immutable data. You wanna tell them, hey, immutable data is anything that cannot be changed. You have your strings, your integers, your floats. Those are things that cannot be changed. But if you have a list of something can always be changed. You can always throw something into a list or take something out of a list or change the key value pairs of a dictionary. So that will be something that is mutable, mutatable. Anything that you can change will be mutable. All right. Anything that you can't change will be immutable. Okay. And now let's check out this buddy here, list. So the list is something that can be changed. It is mutable. All right. So a list usually has brackets, and it can have items or variables within it. So 1, 2, 3. So those are integers, and it can also have mixed data types inside of it. So it has a string as well, sample. It has a float as well, 4.0, and it has a string with numbers in it, 9AE. Okay. So a list, it's a very, very beautiful thing in data, something that you'll use um, for when you're creating data frames or tables with pandas. Something that you'll use whenever you want to reiterate through things, such as with a for loop, and we'll go over that later on. But the lists are very convenient within Python. And as you can see, lists are mutable and can have various types of data within it. Okay. Then you have something called a dictionary. Okay. So with the dictionary, let's go back here. We don't want to spoil the data frame yet. So with the dictionary, they usually have curly brackets and consist of key value pairs. So why do we say key and value? So when you see that curly bracket, you see the key and then you see the value. The key will be fruit here. So that's the type, like what is it? That's what the key is. Then the value will be the exact thing that it is. So we have an apple. So the fruit will be an apple. That'll be the value. Apple will be the value. The key will be fruits. And then with vegetables, vegetable will be the key. And then what type of vegetable is it? It's a broccoli. That'll be the value. Okay. So the key can be a column name, and the value can be a value within a column. Okay, if that makes sense. Key is column name, value is anything within that column. Okay, so let's go here. So now we see a data frame. This is just a table of data, just like you'll see in Microsoft Excel. A data frame is just a table of data. Okay, so let's see here. So we have here it says test, but I would transform that into country. So that will be your key. And then everything within this particular column will be your value. So India, South Africa, England, New Zealand, Australia, these are all your values. And that key will be tests. Okay. But if you look at this from more of a data frame perspective, this is the table. Test is the column name. OD is the column name. T20 is the column name, and everything within it. These are all the rows. So this is row 0. This is row 1. This is row 2, 3, 4. Okay, and then it has all the values within each of their respective columns. Okay. So this is a data frame and how it will look in Python. Now, is it as pretty as Microsoft Excel? Not exactly. Can you make it as pretty as Microsoft Excel? Absolutely. And how can you do that? You can do that by printing out the data frame in a particular format with pandas. Okay, so you can print it out and have it looking much prettier with the pandas. Okay. All right. So here we're gonna start coding. So if you're in Google Colab right now, what you need to do is run the following code to install any of the necessary packages. So you want to pip install pandas, you want to pip install matplotlib, and you want to pip install numpy. Okay. So let's make sure that you're doing that. Install pandas, pip install matplotlib, and pip install numpy. All right. After you go ahead and do the pip install, what you want to do is go ahead and import that data. And if you already have it within your system, you can go ahead and skip the pip install step. So next, what you want to do is import the data onto your Google Colab. Okay. So on your Google Colab, you do import. I'll share this tab instead. Import pandas as PD. Import matplotlib.pyplot as PLT, and import numpy as empty. And then you run it, and then you will have those operational. Okay. So after you've done that, what you want to do is import the video game sales data. And you don't have to do that directly here. But here, what we're going to do is go ahead and take a look at it. So let's go ahead and pause it here. Let's do a import of this data here. So 1 second. All right. And it's almost finished. 1 second. Okay, and now it is imported. So now what we're going to do is go ahead here. Then we can check it out with the pandas. Let's go here. Yes, all slides will be delivered after the lecture for study. Okay, and then what we can do is pd dot read underscore CSV. All right, and now we have our data frame printed out here. So essentially, what happened here is that you'll import your data. So one thing that is good to do whenever you're coding is to pretty much tell whoever's watching what you're doing. So first, you'll put import data. Then you'll put create data frame. Okay. So this is the data that we data frame. There we go. All right, so we're going to import that data and then we're going to create the data frame itself. Okay, so now you can see the full data frame here. You can see the rankings. You can see the name of the video games here in this video game data set. You can see the platforms, so the Wii, the Game Boy Advance, GameCube, PS2. All of that is here, even in Nintendo Entertainment System. And you can see the year that these particular games came out. So this is what we call EDA. You want to look at this data and see what's going on with this data here. You can see the genre here. You can see the publishers, and then you can see the sales here for each of these games. Okay, so it has a lot of beautiful data within it. Um, and one thing that we're going to do next is go over the EDA for it during the next session. But for now, what I want for you all to do is to be able to see this data and see what's happening with this data. So you can even filter out the different columns here by calling for the name here. So calling the name of that column. All right. Well, remember, it's not only called column, but it can be called a feature or a dimension. Okay. So for that column, feature, or dimension, go ahead and type it in. If you want to look at the platforms, you can do that. Okay. Or if you want to look at genre, you can do that. Strictly investigate that one. And then you can see everything that's there. Okay. So this is just this one method of looking at the data. You can also use matplotlib.pyplot to create different types of figures with the Python code. So there's a lot that you can do there. This one. Yep, and then you can also see what all of the genres are by typing in the unique function. So you can see, hey, here are all the genres. We have sports, shooter, strategy, platform, simulation, racing, action, role-playing, fighting, puzzle, adventure, and miscellaneous. Okay, so these are some things that you can do with the data set here. And what I'll be doing after this particular session is sending over the slides so that you'll be able to pretty much import this data onto your system via Google Colab and start playing around with the data set. So when you're playing around with the data set, go ahead and check out all the columns. Go ahead and check out all the cells and things of that nature, and see how you really like it. And we'll be going over more of this during the next session. We'll go over more of the EDA. And after we go through the EDA, what we'll be doing is going through how you can write your for loops, based on it, how you can write conditional statements based on everything that's there. And then what we're going to do is go into the machine learning side of things. Okay. So next week, we'll go through how you can do your exploratory data analysis and also how you can do your machine learning. Okay. So we'll be doing the basics of machine learning next week. So next week will be a very hands-on session where we're going to be going deeper and deeper into the Python coding. And this is to get you prepared for the upcoming capstone. So the capstone that we're doing this particular summer will involve going over the stock market. So this stock market data that we'll be going over will be for NVIDIA. So get ready, because this will be huge. And if you're into trading or Forex, anything of that nature, this will be the capstone for you. And you can also show your job or whatever jobs that you want to get that you've worked on this particular capstone and you finished it. And what we're going to do is put this into a publication as well. So you can put on your resume or CV that you're a part of a publication with the team. Okay. So this is where we'll pause at for now. We'll pause here for now. And let's go ahead and I think Colab is complying right now. It says cannot save. We'll save copy. There we go. So we'll go ahead and put this summer 2024 question. We'll save it here, and then we'll go over the rest next week to go deeper into detail on the EDA, and then we'll start going into the linear logistical regression machine learning techniques. Okay, so let's go here. All right. So to conclude for today, what we're going to do is focus on how you can understand the functionality of a package. So like pandas, NumPy, all of that are packages. Scikit-learn, which is something we'll be using for the machine learning. That's called a package. All right. And how you can check out the documentation. So what you do to check out the documentation is simply Google that package name and put Python next to it. So you can do pandas, Python. You can do NumPy, Python. You can do Scikit-learn, Python. You can do Seaborn, Seaborn. I believe it's BORN or BORNE, Python. And then it'll give you the documentation for that package and how you can utilize the package. Okay. So the encyclopedia for a particular coding package is what is known as the documentation. All right. And remember, a package of functions and classes, a coding package is a package of functions and classes that allows you to code with ease. All right. So here's an example of how it looks for pandas, for example. So if you were to search pandas documentation, Python, you'll see all the different types of functions you can use. So you can use pd.pivot, pd.melt, pd.crosstab, pd.merge, and play around with pandas that way. Okay. So there is a small homework assignment, and remember, you'll be getting all the slides for today. So the small homework assignment for next Friday, and a lot of stuff will be sent in between then, will be to look up the documentation for 5 other Python packages that are used in statistics other than what we learned today. So no pandas, no NumPy, no matplotlib. Find your own packages, find different packages that are utilized in statistics, okay? And this can be for data analytics, this can be for data visualization, and so forth. Read up on those packages, and if you can, play around with it in Google Colab. If you play around with it in Google Colab, go ahead and send over some of the code that you played around with to the emails, either my email or Asia's email, okay? And then write a paragraph explanation of the functionality of each package in an email, not by next Monday, but by next Friday. You can send it by next Friday. Okay. So that's all for now. That's all for today. I know it's easing on 7 o'clock, but if you have any questions or concerns, let me know now, and then we can go ahead and discuss them. But other than that, thank you for a beautiful session on the Python coding.